Hi everyone, and welcome back to Fusion News. I'm Dr. Hazel Lowe. I'm a plasma physicist working on fusion plasma diagnostics at Tokamak Energy in the UK. It's Friday the 4th of November 2022, and this is your Fusion News update. Stories today include 1. Tokamak Energy SD80-HTS hailed as next step to grid fusion. 2. How do neutrons interact with reactor materials? 3. Gigantic 70-foot nuclear fusion gun could change the world. 4. General Atomics announces concept for fusion pilot plant. And I also have a couple of bonus items for you at the end. 1. Tokamak Energy SD80-HDS hailed as next step to grid fusion. This week, there are 2 stories from Fusion Industry Association member Tokamak Energy, a UK-based company working to develop a spherical tokamak-based fusion energy reactor. You might remember that a tokamak is a type of fusion device that uses super strong magnets to hold the fusion fuel in a ring shape to reach the conditions needed for fusion reactions to happen. The triple product describes the combination of the temperature, pressure and confinement needed to achieve fusion, where confinement is a measure of how long a fusion plasma device can keep the fuel contained. Tokamak Energy recently presented data showing that they achieved a record triple product in their SD40 spherical tokamak, measured at a plasma temperature of 100 million degrees C, which is several times hotter than the centre of the sun, in a plasma less than 1 cubic metre in volume. This is 15 times smaller than any other tokamak which has achieved this temperature, and it's a record triple product for any private fusion company. Tokamak Energy also announced that they're developing ST80-HTS, the world's first spherical tokamak to use high temperature superconducting magnets, which can operate for longer than conventional magnets without overheating. By increasing the length of a plasma pulse from less than a second to several minutes, the team expect to reach a triple product close to what is required for a commercial fusion plant once they start operating the new device in 2026. This will inform the design of the company's pilot plant, STE1, which they hope will be the first fusion device to produce more energy than it uses and deliver clean, sustainable energy to the grid in the 2030s. Chris Kelsall, CEO of Tokamak Energy, said, "High performance in smaller spherical tokamaks is the key to commercial fusion power. Our latest achievement further substantiates this optimal route to clean, secure, low-cost, scalable and globally deployable commercial fusion energy. We're proud to have achieved this result in collaboration with the Princeton and Oak Ridge National Laboratories." Regarding SD80-HDS, Kelsall went on to say that our roadmap for pioneering commercial fusion energy has the potential to deliver a game-changing solution. Our next high-field spherical tokamak, the SD80-HTS, has the goal of demonstrating the engineering solutions needed to make commercial fusion a reality, providing the foundation for the global deployment of fusion power plants in the mid-2030s. This would provide humanity with access to clean, sustainable, on-demand and low-cost energy wherever and whenever it is needed. 2. How do neutrons interact with reactor materials? This week, Phys.org reports on 2 recent publications from the University of Kentucky about how neutrons interact with carbon and silicon. These materials are often used inside fusion devices, so knowing exactly how neutrons affect these materials is really significant. As regular viewers of Fusion News will know, many fusion devices use a fuel made up of 2 isotopes of hydrogen, called deuterium and tritium. When these elements are heated up and forced together, one product of the fusion reaction is neutrons. The neutrons are produced with a lot of energy, allowing heat to be harvested from the fusion reaction. However, the same neutrons can also damage parts of the reactor, so finding materials that can survive being bombarded by lots of these energetic neutrons in a short space of time is a big challenge if you want to build a fusion reactor. A DOE press release explained that neutrons scatter from nuclei in ways similar to how balls scatter in a billiards game, except the scattering is ruled by quantum mechanics, as well as by conservation of energy and momentum. Researchers need a detailed knowledge of exactly how these uncharged particles interact with materials, because these nuclear data are embedded in modelling and simulation software. These data also determine how well a system will perform. In this research, scientists measured the energy and angle dependence of neutron scattering from silicon and carbon. The results provide answers that scientists can only uncover through experiments. 3. Gigantic 70-foot nuclear fusion gun could change the world. The next story is about the so-called BFG, or Big Friendly Gun, a prototype fusion device developed by Fusion Industry Association member First Light Fusion based in the UK. The BFG is a 2-stage gas gun, which uses 6.6 pounds of gunpowder to launch a high-velocity piston into a reservoir of hydrogen gas. The hydrogen is compressed to 10,000 times atmospheric pressure, and this huge pressure is used to launch a projectile at a target containing fusion fuel. The idea is that this impact compresses the fusion fuel, generating conditions in the target needed for fusion reactions to take place. CEO Nick Hawker explained that, "I like to say that magnetic fusion is like a furnace. It's an always-on hot process because the particles are going around the donut, whereas inertial fusion is more like an internal combustion engine. It's a pulsed process where you have a repetition rate, and the energy per event multiplied by the frequency gives you the power. Each target will release about the same amount of energy as a barrel of oil. It's literally 1,000,000 times more energy dense than a chemical reaction. It's more energy dense than nuclear fission as well." 4. General Atomics announces concept for fusion pilot plant. The last story today is about another next-generation fusion device, as US company General Atomics, which operates and manages the D3D fusion experiment for the US Department of Energy, has announced their plans to develop a compact Tokamak-based fusion pilot plant. As I mentioned earlier, one option for fueling a fusion reactor is to use deuterium and tritium gases. And if you watch the channel regularly, you'll know that making, handling and storing the tritium is quite a challenge. Researchers are trying to work out how to make the inner wall of the fusion reactor, also sometimes called the blanket, so that tritium is produced in situ, using products of the fusion reaction, and can be harvested and reused. General Atomics are working on how to create such a modular reactor blanket for tritium breeding, and also collaborating with Savannah River National Laboratory on tritium handling. Another interesting part of General Atomics' approach is that they have developed the Fusion Synthesis Engine, or FUSE, which is a massive tokamak simulation code that they can use to study and optimise how a fusion pilot plant might work. Dr. Wayne Solomon, Vice President of Magnetic Fusion Energy at General Atomics, said, "The General Atomics fusion pilot plant is a revolutionary step forward for commercialising fusion energy. Our practical approach to FPP is the culmination of more than 6 decades of investment in fusion research and development, the experience we've gained from operating the D3D National Fusion Facility on behalf of the US Department of Energy, and the hard work of countless dedicated individuals. This is a truly exciting step towards realising fusion energy. Here's hoping they can find a way to turn this plan into reality." And now for the bonus items. There was plenty in the news about fusion this week, including a couple of articles about China's largest tokamak, HL2M, reaching a plasma current of 1 million amperes. The team at HL2M are now preparing to try and reach a plasma temperature of 150 million degrees, which is 10 times hotter than the centre of the Sun. Also, the UK government's Spherical Tokamak for Energy Production, STEP, was back in the news this week, with an article discussing the desire to reach net energy production in the range of 100 megawatts, roughly enough to power 100,000 homes, in the 2040s. And finally, CBS has an introductory article about nuclear fusion, including some awesome videos showing progress at the International Thermonuclear Experimental Reactor currently under construction in France. That's all for Fusion News this week. Please subscribe for more Fusion News and check out the links in the description below if you want further information. And don't forget, you can also listen to Fusion News by subscribing to our podcast. Thanks for watching.